Hi guys, welcome back to the second part of this example. In this video we are going to use Asyncio to load multiple data frames concurrently from the database. Actually we are going to load the tables that we created in part 1 and then we are going to perform some transformations. There is no much logic behind those transformations, but the purpose is to demonstrate some of the PySpark functions. We are also going to see how to partition or repartition the data and how to create user-defined functions in PySpark. It would be an interesting video. Let me scroll down to the main function. Here on our main function, first of all, if you are on Windows, you have to set the event loop policy, asyncio.windowsSelector event loop policy, and then we have to define the table names inside the list. So I created this list with all the table names, and then we create the queries. PySpark uses queries in order to actually get the data from the database and return the results in a data frame. So using list comprehension here, we create the select queries for each table. Then we pass the queries list on our main function and we use asyncio.run in order to execute our main function. Moving on to the main function, you will see here what we actually do is create asyncio tasks and pass the query, each query. So we use list comprehension here. And for each query, we execute the read from database function and we pass the query. We need to use asyncio.createTask in order to create a list of asyncio tasks, and then we use asyncio.gather and we unpack the list of tasks here. Remember, you have to use the await keyword in order to allow asyncio to finish executing the code. Now let's see the read from database function. Up to the top here, we pass the query as a parameter. It's pretty easy actually to get data from the database using PySpark. You have to use the Spark, which is the Spark session that we created here. Always just create a Spark session like as a global variable. It's more convenient, and you can create a Spark session using the Spark session.builder.appname and .get or create. Of course, you have to import Spark session from PySpark.sql before you do that. And here inside our function, we have to use spark.read.format JDBC and we pass the options. Now you can use these options, you can pass these options as parameters, whatever you want. I've put them here just for for the video, but usually you have to pass it as variables. Now we have the JDBC URL, the driver, the query that we passed as a parameter, the username and the password, and then we use .load, and that returns the results into a PySpark data frame here, and we return the data frame. If we go back to our main function, you will see that we return 4 data frames because we queried actually 4 tables, the 4 tables that we created in part 1, and now we are going to read them from the database and store them on those data frames. And you can do that. So you see here, all the data frames are on the same line. This is good about Python. You just put them on the same line and sequentially, and it will return all the data frames sequentially with the sequence we have here. First of all, the ingredient data frame, the type data frame, the category data frame, the class data frame, and then we perform a .show so we can see that the results. Let me run this so you can see what we get from the database. It will take a bit of time to spin up the cluster. That's the downside of PySpark if you are not using big data, but on these examples, we are using PySpark to demonstrate how we can use it on the cloud instead of using pandas, because pandas is for small data sets, PySpark is for big data sets. Now you can see we have printed 4 PySpark data frames with all the columns here, and this is how you read from the database. using PySpark. Okay, now that we have loaded the data into data frames, now let's see what repartition actually is and how you can repartition the data. Let me comment that out and move on to the next task. So we can repartition the data. Again, I'm using Asyncio and I create separate tasks for each data frame. In the repartition and save function, we pass the data frame and the export folder. You can give whatever name you want. I use the data frame naming convention just for my own convenience. If we move to the repartition and save function, you will see, first, let me print the number of partitions that we have now. And in order to do that, in order to call this function here, the getNum partitions, that will give you the number of partitions, you have to convert the data frame to a resilient distributed dataset first. You cannot call this function in the data frame. So let me do that and run this. And you will see the number of partitions at first would be 1, and then we repartition the data actually into 5 partitions. Before we partition, all the data is stored in one partition, but when we perform a repartition, then it stores the data into 5 different partitions. Now, if let me uncomment this, and let's repartition the data and save them as text files in our directory. It could be easier to see how PySpark partitions the data. Let me run this. You will see under this directory how PySpark partitions the data, and for each data frame we provided a separate Ex3 folder. Let me switch to the other screen. In our local directory we created 4 different folders here. As you can see, each folder corresponds to one data frame. Now, what you will see if we go inside that folder, you will see this .crc, which has the metadata for each partition, and then here, that's part, and 0000 is the first partition. If you open that using a notepad, you will see the first partition here. It contains only 50 rows. It's in row format because we have used RDD, resilient distributed data frame. It's not a PySpark data frame. It's a resilient distributed data set. And here, that's the second partition that contains another 60 records, and the third partition contains 58 records. You see, PySpark split the tables into 5 partitions. You can check the same for the rest of the data frames. You can see for glass, that's a separate partition. It created 5 separate partitions for each data frame. It's pretty cool actually, if you think about it. Now, what if we want to partition a PySpark data frame and not a resilient distributed dataset? Then there is an option to partition the data, and it's this option. So the data frame, you provided the data frame .write .option header true, and then you have this partition by option here, and you partition by column. Mode overwrite or append, whatever you want, and .csv, we export in CSV format, and we provide our local directory. Now, if we scroll down to our main function, and here we have this part that we call the partition by and save function, and we create Asyncio tasks, of course, again, and we pass the data frame and the export folder and the column that we want to partition by. In the first column, in the first data frame, we want to use the ingredient column. The second data frame, we have to use the type column or the category column or the class column for the class data frame, etc., etc. You can partition by whatever you like. Usually you partition by date or something that you can actually partition. Let me save and run this, and you will see now in our local directory different partitions for each data frame. We would split the data frame into 5 different partitions. Of course, I forgot to mention we have to use asyncio.gather unpack, all these tasks. That's the Asyncio part, but now we're focusing on the partition by part for the data frame. Let me switch to the other screen. In our directory, again, you will notice 4 different folders, one for each data frame. If we go inside one folder, here we split the data frame in 4 different partitions based on the category, right? Because we have 4 different categories for the drinks, one for cocktail, one category for ordinary drink, one for shake, one for shot. Now, if you go here inside the cocktail, you will see a CSV file, right? Reading partition data is pretty easy. Actually, it's exactly the same as reading non-partition data. So we are reading a CSV file here. We have to use spark.read.option header because we exported the data here using headers, and .csv, and you provide actually the path that you want to load the data from. Now, what's the difference between non-partition data? The difference is that you have to provide the exact path for the partition data. Let me show you this here. Here in this function, the read partition data function, we provide the input folder, which essentially would be the exact path for the partition data that we want to read, and then we return the data frame. If we go back in our main function, and let me comment this part out and uncomment the rest, and let's see here. Now, what we need to do is, again, we are using Asyncio, we create tasks, and we pass as parameter the exact path for the partition data. So essentially, you query a folder. You have to use ingredient equals gin or type equals alcoholic or category equals cocktail or glass equals cocktail glass, right? This is how you query partition data. And then let me save and run this, and I'm going to print the results. So we are going to see the data frames that we have queried, we are getting from the partitioned data we have queried. So let's go to the first data frame, and you will see that's the first one. No, this is the first one. So the first one would actually bring back all the results that have ingredient gin. It's not going to bring everything. It's only going to bring these drinks that contain gin as an ingredient. In the second data frame, it's going to bring back all the drinks that are of type alcoholic, and the third one of type cocktail, and the fourth one, they have cocktail glass as glass. And this is how essentially you query the folders. This is how you filter the data, and you get back, the data from the partitions. It's pretty convenient actually to do that. And now let's move on to the next one. The next thing we typically do is to perform some transformations to the PySpark data frame. So here we call these functions and we pass the data frames as parameters. Let's go to this function here, the perform transformations function. You will see that the first thing I do is to rename some columns. And the reason is when we join PySpark, it's not like in SQL that it provides a new name to duplicated columns. It doesn't provide a new name. It has the same name. It leaves the same name for the duplicated columns, and that is a problem, right? Because imagine this data frame here has column ID, and the category data frame also has column ID, and the glass data frame also has a column ID, and we are going to join all those tables, and there will be 3 or 4 ID columns, and you don't want that. So you have to rename the columns before you join the tables. What we want to do here is to join the tables based on ID. And ID and drink, all the data frames have those columns, ID and drink, so we would have plenty of duplicated columns, and this is why we have to rename a few columns before we join the tables. Now, you can rename a column using this command here, dot with column renamed. You select the column you want to rename and you type the new name here. We do that for these columns as well, for the drink columns, drink type, etc., etc. So we rename a few columns here so we don't have duplicated columns. And then what we do is to join the data frames. You can do that by using ingredient df. So that's the first data frame. We are going to join it with the type data frame based on ID, and we perform an inner join here, but you can perform a left or right or outer or whatever type of join you want. I perform an inner join here, and then you have to type the first data frame dot join, then you provide the second data frame, and then you provide the condition for the join and what kind of join it is, and then we perform the same inner queries for the rest of the data frames. So we join all the tables, and let me print this result here. So here we display the new data frame, the joined data frame. It has all those columns, and as you can see, we have ID and ID type and ID glass, and all those IDs are all the same now, but we have different names now, column names. So we don't, and since we don't want those columns, we can drop them. And we can do that by using this command df.drop, and you select the columns that you want to drop, and then let's display again the data frame with all the remaining columns. It will be more easy on the eye to see what we get back now that we have less columns. Okay, here we are, and we have ID and drink, ingredient, type, category, and class. So we create a new table based on the joins, and then we drop some columns, and now we have a final table here that we can play around with. A final PySpark data frame, actually not a table, a PySpark data frame that we can play around with. And the next thing we want to see is the user-defined functions. Now, a user-defined function is pretty easy to actually do that in PySpark. We have to define a function here. Let's define this uppercase function. We pass a string and we convert the string into uppercase. It's pretty simple, of course, but here is how, the purpose is to demonstrate how it works. And if we go back here, we need to use the UDF keyword, open parentheses. We use the lambda function. So for each actually element, we use uppercase, and string type. This is the type we return from the user-defined function. So that's now a new function here, and we can use it in our PySpark data frame. Now, of course, the UDF here, this keyword, you have to import it in the PySpark SQL functions. You have to import UDF and also columns. You will see in a little bit why. And here we can use the user-defined function in a specific column. So you can do that by using dataframe.withColumn. You select the column you want to use in the user-defined function, and then you pass the column again that you want to apply the user-defined function by using this call keyword here that we imported from the PySpark SQL functions. And this is how you apply and user-defined functions. Let me print now the data frame after applying the user-defined function, and you will see that the drink column now has only uppercase letters, and this is how you create a user-defined function. It's very easy and very useful. You can see everything is in uppercase on this drink column here. And moving on to the next transformation, that would be the translate function. Here it is. You have to import it from the PySpark SQL functions. Here you can see I have imported the late UDF called translated substring. These are some of the functions that we are using in this example. What translate does is replaces character by character on a column, on a PySpark column. So here you provide the string or a column, in this case the ingredient column, and it replaces each character. So I is going to be replaced with I capital, but you can replace it with Y or whatever letter you want. And but here and then G, it replaces G with G or V or whatever you want again, and N with N capital. Now if we run this, it's going to replace, so it replaces character by character, not the whole string, right? It's not going to replace this string with this string. It's going to replace this character here with this character here, this character here with this character here, this character here with this one. If we check the ingredient column here, you see we have replaced all the letters. Now let's do that again, and then we have the substring column, right? And the substring is, as you can guess, we get the substring of a column. So in the category column, we get only the first 8 letters. Here, ordinary or cocktail. So we are going to exclude the underscore drink on this column because it's more than 8 letters. And be careful though, because the index starts from 1 and not from 0 as it usually does. So let me run that and print, and you will see what substring does, but I'm guessing you already know the answer. And while we are waiting, let me uncomment this one. And here you see in the category column, we only took the first 8 letters. This is how you can get a substring. Now, the next thing we can do here is order by column, and you can use order by or sort. It's the same thing. And then you use the call function. You select the column you want to sort. This is ascending mode, and this is descending mode. That's for the category. So you can play around with the sorting part or order by, whatever you want. And there are also a few other transformations that I would like to show you. The first one is how we can use filter. So to filter the data, like using a where clause in SQL, you can do dot filter or dot where. You can do both. It's the same thing. You select, if you have multiple conditions, you have to open brackets inside the brackets, and you have to select the column. Isin is, the equivalent in SQL is like in, and here in PySpark is in, and here I provided a list with the variables I want inside this list, and then you select the column, the ingredient, and let's say we don't want the Applejack, so everything that is different to Applejack, and we can print that also. So let me show you this one. Let's comment this out and run this one, and we will see the latest results, the latest data frame. Another thing I would like to show you while this is running. Now this is the like function. You can do so. You can do dot filter column. You select the column and you do dot like, and you provide the string that you want to find. Now this is, as you can see, this is the last data frame after the transformations, and I can run it for using like, and you will see what that gives. You don't have to assign the the transformation to a data frame, you can just, if you want just to see what results we are getting back, you do a dot show. And here now we don't have anything. Why is that? Yeah, we actually, here we filtered, so now we don't have any cocktail glasses under the glass column. That's why it brought back nothing. But you get the point, right? What we can do instead of using PySpark data frames, there is another trick in PySpark, which is actually even better sometimes. Because if you have an ETL background and you are pretty good at SQL, this could be very, very handy. It will come very, very handy to you, because we create a temporary view, uh, and then we actually select, we perform all the queries in SQL language on that view. So when, if you want to create a view, you do a dot create or replace temp view, and it's going to create temporary view. Now after the session, this will be destroyed, of course, but if you want, it's not going to be persisted. But if you want a temporary view to perform SQL, that's how you create that. And then you have to use spark.sql. So this is different. It's not PySpark, it's Spark SQL. And you use that spark.sql, and inside here you select a query, right? So let me remove that, comment that out, because we have filtered the data already. But let's bring the data back into the previous state and have some data to create a temporary view here. And from the temporary view, let's say we want to select the drink, where the type is alcoholic, the category is cocktail, and the glass is in old-fashioned glass or cocktail glass. And you will see that we can print the data frame again dot show, because it will return the results in a data frame. We have assigned the results into a data frame, and we can see the data frame, or we can just straight up use dot show, and it's going to show the results exactly without assigning the data into a data frame. Here we select ingredient, class, and count. We perform a group by and then order by. So if you are coming from an ETL background, this is very, very useful. You don't have actually to learn, all this PySpark syntax. You just create a temporary view, and you perform a very complicated query that otherwise would be very, very difficult if you don't have a PySpark background. Now let me save that and run this, and you will see two data frames now, and that would be the results of spark.sql. And this would bring us back this drink column. Here you are. This drink column here, we have 4 drinks based on those conditions that we applied. And then we have a second data frame with a group by clause and the order by and the count, etc., etc. Now, Spark SQL is one of my favorites, because actually I'm coming from an ETL background, so I can perform very complicated queries without using PySpark syntax. This is everything for today. We learned some cool stuff in PySpark. If you like the video, click the like button and subscribe to the channel, and I will see you in the next one.